Now, when we talk of refraction, then there's also one property of light. And you realize that when we're talking about the property of light, we also made mention that light can be refracted. And so now when we talk of refraction of light, there's one property of light. Now, you realize that when light travels from one medium to another, there's a change, number one, in speed. As one light moves from one medium to another, there's a change in speed, there's a change in direction. And basically, that is what we are going to explain. And that normally explains the whole concept of refraction, as I'm going to explain. So when a ray of light moving through a transparent medium enters into another transparent medium of different densities, the direction of the ray changes in the second medium. And so the change in the direction of the ray in the second medium occurs at the boundary that separates the two media. And as a result, because there's a change in direction, it affects the speed. So for instance, let me give you an example before I even define what refraction is. And so you have two transparent mediums here of different medium, different densities. Now let's assume that this one is traveling from air. Air is transparent medium. So this one is moving from air. Now, when they move from air, definitely we have that line that separates it. What you can call it, what they call it, the normal. And there's another medium. Now, depending on the two densities, so if for instance air is moving from if light is moving from air and it is moving into water, you realize that water is denser than air. And so now we can, the light ray will change its direction, And so when it changes the direction, it will either bend away from the normal or bend towards the normal. It will either bend away from the normal or bend towards the normal. And because it is moving from a less dense medium to a denser medium, it will bend towards the normal. And so this will bend towards the normal. Let me give you an example. You realize that when you're walking and you are walking on a normal ground, and perchance you get to a point whereby the place is maybe muddy or something, you realize that when you are walking in the mud, your walkings changes. Your walkings change, or the way you walk, the rate at which you are walking on the normal land without the mud, you realize that it changes. And so just because when you're walking at the on the normal land without the mud, you were moving very fast, but because you are now in the mud or the place is slippery, you would have to relax. And so there's a change in your speed as a result of your change in direction and so on and so forth. So basically that's what happens here when we're talking about refraction. And so refraction can be defined as the phenomenon whereby there's a change in direction and velocity of light when light travels or when light traveling in a transparent medium enters into another transparent medium of different densities. So it's a phenomenon whereby there is a change in direction, and that change in direction affects the velocity of the light when light traveling in the transparent medium enters into another transparent medium of different densities. On the other hand, you can also define it this way: it's the bending of light when it moves from one medium to another of different densities. And so when light moves from one medium to another medium of different densities, there's a change or there's a bend of this light ray. And that phenomenon is what we call, or what we term as refraction of light. Refraction of light. That's what we term as refraction of light. And so when light moves from one medium to another medium of different densities, and the light bends, we call it refraction of light. That phenomenon we call it refraction of light. And I said, now the light can either move from a denser medium to a less dense medium, or a less dense medium to a denser medium. Now, when light is moving from a less dense medium like air into a denser medium like water, light, this is the incident ray. This is moving from the less dense medium. Now, when it strikes, this is the refraction boundary, the boundary that separates one medium from another. Now, when it gets to the medium, the boundary, it moves towards, or it bends towards, what do you call it? The what do you call the normal. And so this medium is air or less dense medium. This medium is air, so we can say that this is air. So this medium is air. This is water. This is water. Now medium one, this one is less dense. This is denser. On the other hand, when we are to reverse the action, when light is moving from a denser medium to a less dense medium, the refracted ray bends away from the normal. Because, for instance, when you are walking in the mud, you take your time. Now, immediately you get out of the mud, you realize that your speed changes, it increases. And so then it bends away from the normal. And so if you have to reverse the reaction, and we have something like this, one light is moving from, what do you call it, water. Let's say this is water, and it gets into air, it will bend away from, the normal. And so this is air. It can even be glass. It can be moving from glass into air, like your glasses. Your glass can be one this thing. What goes on is refraction. And so basically that is what it means. And so refraction is the bending away or towards of light rays when it moves from one medium to another medium of different densities. That defines what refraction is. Now, some effects of refraction is, now when that occurs, there's a change in direction. That's number one. Number two, there's a change in speed. That is it. There's a change in speed, and there's a bending away of the light, or there's a bend of the light. These are two or three things you consider. And one also difference between reflection and refraction is, under refraction, you're talking about a media or two medium. Under reflection, you're talking about just a poly surface or just a medium, just one surface. But here, I'm talking about two surfaces, moving from one surface of different density, moving from one surface of a density to a different surface of different density. Basically, that's what you are seeing under refraction. Now, let's talk about some effects of refraction. You bear with me that when you place your pen or a stick or something, or when you immerse a stick or something in water, you realize that when you look into the water, it appears to be bent. The tip in the water appears to be bent, and it is as a result of the light rays traveling from the air into water. So it makes the part of the stick in the water appears to be bent. Are you getting it? Appears to be bent, and so that's some of the effects of light, of refraction. Now, when you go to a swimming pool or well normally appears to be shallower than it is in reality. So when you go to a pool and you are standing behind the pool, because light is traveling from the air into the water, it makes the water or the pond or the pool appears to be shallower than its reality. So sometimes you might think that, oh Charlie, it is very shallow, and you might end up even hurting yourself because you just throw yourself and by the time you realize you are inside somewhere that you can't even get out. So because of refraction, a pond or a well or a swimming pool appears to be shallower. Now, a glass block placed on a newsprint makes the letters appear closer to the top of the glass. So when you place a glass block on a book or like on a printed paper, the letters appears to be on top of, what do you call it, on top of the glass, and it's as a result of, whereas in reality it is not. And so that is one advantage or one effect of refraction. Now, when you also place a coin in a bowl, invisible to the observer at E becomes visible. So when you place a coin in a bowl, which is invisible to the observer at E becomes visible when the water is poured into the bowl. So when you place a coin and you pour water in it, it makes it visible. Let me put it that way. Now we also have, it's also governed by two laws. And the first law states that the incident ray. Now looking at this is your incident ray. And so this is being incidented, and this is your refracted. And so this one is your refracted ray. This is your refracted ray, and this is your incident ray. So incident and refracted. So definitely the angle which is formed between this and the imaginary line, which you call the normal, is the angle of incidence, and the angle here is the angle of refraction. The same for this too. The angle of refraction. So that is it. Now you better know if you have to trace, this should have been the original path. The original path should have been something like this. Should have been something like this. So basically that is it. Now it's governed also by two laws. The first law states that the incident ray, the refracted ray, you know, when we're talking about the reflection, we're talking about the reflected ray. We are talking about the refracted ray. So the incident ray, the refracted ray, and the normal at the point of incidence all lie in the same plane. So the incident ray, the refracted ray, the normal at the point of incidence all lie in the same plane. Number two, we call it the Snell's law. The Snell's law. The Snell's law. And this is how it says. The ratio of sine of the angle of incidence in one medium to that of the sine of angle of refraction in another medium is constant for two media. And so that means the sine of the angle here in this medium, you realize that there's one medium, to that of the sine, the ratio of the sine of angle of this angle in this medium to that of the angle in this medium is constant for any given is constant for two media. It's constant for two media. That means two media is this. It's constant. So mathematically we can say that the refractive index, I'll explain refractive index, is equal to the sine of this. This we call it another one, we call it the Snell law. The second law we call it the Snell law. Snell law. So the angle of incidence all over angle of refraction. And so the Snell law states that the ratio of these two is the refractive index. The ratio of these two, which is constant for any given pair of media or any given two medium, is constant, and this is the constant. That defines the two of them. That defines the ratio. And so the ratio of the sine of angle of incidence in one medium, so the sine of angle of incidence in one medium to the sine of angle of refraction in another medium, there's the angle of refraction in another medium, is constant for two media. And so there's a, you know, you're talking about two media here. So 1, 2 medium, 1 medium, 2. And so two media, and it is constant. So there's a constant. And a constant, we call it refractive index. When we get to that, we explain refractive index. When we get there, we explain. No, the constant is called the refractive index of the two media. So the constant, we call it refractive index. The constant, we call it refractive index. And so that is it. And it is denoted by this. This is how it looks like. Some also write it this way, like the mean. And some people write it this way. So that is it. Let's go back. This is normally is sine I all over sine r, and this we are going to use this to listen. So we can see that light traveling from medium A, light travels from medium A and enters medium B. So this is the two media we are talking about, and it's equal to the sine of angle in this medium A all over the sine of refraction in this medium B. Basically, that is it. Now, I said that when we are talking about refraction, we can talk about the speed too. And so, in also considering the refractive index, we can also consider, or we can also talk about the refractive index in terms of the speed. Now, you realize that the speed, the first speed will be in medium 1, because it travels from medium 1 before it gets into medium 2. So the speeds are different. So we can say refractive index can also be equal to the speed in medium 1, speed in medium 1, speed in medium 1, in medium 1, or medium A, all over speed in medium 2, all over speed in medium 2, all over speed in medium 2. So you can also talk about that. So speed in medium 1 all over speed in medium 2. So you can also relate refractive index in terms of the speed in medium 1 and also the speed in medium 2. Now, you realize that when we're talking about the effect of refraction, we also say that a pond appears to be shallower than its actual depth. And so now we can also relate this one in terms of the apparent depth and actual depth. And so refractive index can also be equal to, so let me use, can also be equal to what do you call it? Actual depth all over real depth. Sorry, real depth is the same as actual depth. Real depth or actual depth all over the apparent depth, all over apparent, all over apparent depth. So we can also relate this refractive index. So refractive index, we can consider them in terms of three distinct formulas. The formula number one is the Snell's law, which is the sine of angle of incidence, the ratio of sine of angle of incidence in one medium all over that of angle of refraction in another medium. So sine I all over sine R. So when you are given the question and the question is in angles, that's what basically we are going to use. Now, when the question is in speeds, relate them in terms of their speed, then you can go and say that speed of the light in medium 1 all over speed of light in medium 2. Now, when it is in depth or distance, then we can say that real depth all over apparent depth. Real depth is actually the depth. So, for instance, if I have, I'll end the distance very soon, so that I prepare for the next class. For instance, if this is a pond, you realize that when the person standing here, the observer standing here, sees the pond to be maybe at this depth. That is how he sees. But actually, the real depth is the depth from here to this point. But because of refraction, the observer sees the point to the distance to be from here to here instead. So this one becomes the apparent depth. It is not the real depth. It's a deceiving depth. So we call this one the depth from here to here, where the observer sees or thinks is the real depth, is what we call the apparent depth. And so APP. Then this one is the real depth of the water. And so this is the real depth of the water. And the difference between the real depth and the apparent depth, we call it displacement. So that's the difference between from here to here. We call it displacement. D-I-S-P. We call it displacement. So this one displacement. There's the apparent depth and there's the real depth. So when you're asked to find for the refractive index, given the depths, you're going to use real depth all over apparent depth. When you're asked to find for refractive index, given the speed, you're going to use the speed in medium 1 all over medium 2. When you're asked to find them using their angles, you're also going to use sine I all over sine R. I hope I've made myself clear. Have I made myself clear?
Yes, sir.
So next time we are going to look at reversibility of lights and critical angle. We are going to finish with the rest of the refraction. Total internal reflection, you are going to finish with that one. Then we do reflection at curved surface. The one we looked at was reflection in the previous classes, reflection on the plane surface. This one I'm going to look at reflection at curved surface and how images are formed on the curved surface, the positions. That is a little bit lengthy. We are going to look at them. Then from there we do lenses. That one we are talking about refraction on a lens. Normally lens goes with refraction. So we are going to look at that one. Then we do refraction through prisms, where we talk about the colors, the diffraction of light. And from there, yes, we talk about the secondary colors, the primary colors, the primary colors, the magenta, secondary colors, the magenta, the cyan, and the rest. The primary colors, the blue, green, and that is it. So blue, red, green, these are the primary colors. We are going to look at all of them. Then For the what you call the optical instrument, I'll let you go and read about it. I have notes on light. I wish I could give it to you so that, or I can put it on YouTube so that you go and watch it. I've thought this is, I think all the ones I'm talking about, I have videos on all of them. I don't know if I should give it to you so that you go and listen, but whichever way, that is it. So we have commerce tomorrow, God willing. Well, thank you very much. I have to prepare for the next class. Make sure you attend the next class. It's 10:30. So yeah, talk to me. Ruben, you are talking. I can't hear you. The network. So you just WhatsApp me with it. Yeah. I can't hear you. So just WhatsApp me with anything you want to tell me. I don't know. I'll upload it there. I'll upload it.